Hello students, so we are doing limits and derivatives. Next part is trigonometric limits. Okay, so we'll see some standard trigonometric limits which we will be using for solving limit problems. So first is limit as x tends to 0, sine of x upon x is 1. Okay, same way limit as x tends to 0, tan of x upon x is 1. Okay. Then limit as x tends to 0, 1 minus cos x upon x is 0. Limit as x tends to 0, 1 minus cos x upon x square is half. Okay, so you have to keep this limits in mind. Okay, we will be using this limits. Let's solve some problems. Limit as x tends to 0, sine ax upon sine bx. Okay, so we have to convert this to sine x upon x. So whatever the this is our degree, that is angle, right, ax. So whatever the angle is, that angle has to be in the denominator. So we have to divide and multiply, that is dividing by ax and multiplying by ax. The same way we have to do the same thing in the denominator also. Okay, so that when we take the limit as x tends to 0, sine ax upon ax becomes 1. Okay, sine bx upon bx becomes 1. So this remains ax upon bx. X gets cancelled and you will get a upon b. Okay, second question. Limit as x tends to 0, sine 8x upon tan 3x. Same, that is, we have to multiply by the angle. So multiply and divide. 8x into 8x, and this is tan 3x, 3x into 3x. Okay, so that this becomes 1 and this also becomes 1. This gets cancelled and you will get 8 by 3. Okay, next question. Limit as x tends to 0, sine 3x plus 7x upon 4x plus sine 2x. Okay, so again we have to divide and multiply by 3x. Okay, so this 3x comes here and there is a plus sign, so 3x comes here also, and we are multiplying by 3x. Same thing, you have to do it in the denominator also. So here 2x will come, 2x, 2x. Okay, so this thing becomes 1. Again this also becomes 1. This will get cancelled. This gets cancelled. This gets cancelled. So there is no x term here. This is 1. 1 plus 7 by 3 upon 4 by 2, which is 2. 2 plus 1 into 3 by 2. Okay, so cross multiplying you will get 7, 10 by 3 into 3 into 3 by 2. So 10 by 5 by 3. Okay. Next question. So here limit as x tends to 0, sin square 8x upon x square is given. Now you should keep in mind that if it is given sin square of x, okay, then your the number which is in the denominator should be x square. That is whatever the degree here, okay, that should be matching with the denominator. But here the angle is 8x. So we want 8x in the denominator, right? Like this. But square term is given. So this becomes square and this is also square. Okay. So that this square term with this square becomes 1 when x tends to 0. Now these two terms remains. In this, x square gets cancelled. Only 8 square remains. So the answer is 64. Okay, you have to show this by steps. Okay, I have done it directly. This is our standard trigonometric result, that is answer is half, right? So trigonometric limit. So here you have to make use of the trigonometric identities, half angle formulas. Okay, that is cos 1 minus cos x equal to 2 sin square x by 2. So I can substitute here 2 sin square x by 2. Okay, upon x square is there. So here the angle is x by 2, right? And sine square is there. So we have to multiply and divide by x by 2 square. Okay, so that this term becomes 1 as x tends to 0. Now I'll write here 2, this is x square by 4 and this x square is there. Okay, so the final answer is half. Okay. Next question, 1 minus cos x upon sin square x. Now here either you can divide by x, okay. I'll divide by 1 minus cos x divided by x square, okay, and multiply by x square. That x square will come in this to this denominator, okay. So we wanted here x square because this is sine square is given. So this becomes 1 and as x tends to 0 this becomes half. So answer is half. Okay. Another way to prove this is without using trigonometric limit. That is, you can simplify this. That is, if you know the trigonometric identities, this is 1 minus cos x, sin square x can be written as 1 minus cos square x. Correct? 1 minus cos square x can be written as this a square minus b square formula. So a minus b, a plus b. So you'll get 1 plus cos x. Now when x is equal to 0, okay, cos 0 is 1. So you'll get here 1 upon 2. Okay. Next question. So here limit as x tends to 1, 1 plus cos pi x upon 1 minus x the whole square is given. Okay. Now to use trigonometric limits, we need x tending to 0. Correct? So we have to change this limit so that we can use the trigonometric limits. Okay. So to change that, we have to do here substitution. So if I substitute this 1 minus x at some h, okay, then if I put x is tending to 1, means 1 minus 1 will become 0, right? So h will tend to 0. So by substitution, we can change it. This becomes h tending to 0. Okay, 1 plus cos pi. In place of x, you can write here. So h I am taking that side. 1 minus h, correct? 1 minus x is h, so h square. Okay. So you have to make use of trigonometry here. So cos pi minus pi h. Okay. So this is cos pi. Pi is 180 degree, correct? So we are subtracting something. So the angle is here in the second quadrant. Pi means there is no transformation, means cos remains cos. Okay. In the second quadrant, sine and cosec are positive, rest all are negative. So the sign changes here. So it becomes minus cos. Cos pi h upon h square. Now here h square is given. We can make use of the identity, the trigonometric limit, that is as limit x tends to 0, 1 minus cos x upon x square is half. Okay, so we have to just make the angle equal. Here h square is given, we want pi square. So we'll divide and multiply by pi square. Okay, so that this thing as h tends to 0 becomes half, and there is a pi square here. The final answer is pi square by 2. Okay.